sides and stuff like that. So when we're talking about the surface area of a pyramid, just like last week we had surface areas of prisms and surface areas of cylinders. Remember how the cylinder formula was the exact same thing as the prism? Well, cones are kind of the same thing, but we're going to talk about in terms of pi in a little bit, but for right now, we'll start with the pyramid. What happens now with a pyramid is that you have a different term that we have to look at. We have to look at what's called a slant height. A slant height, should I have a visual aid? A slant height, excuse me.
Wow. How long have you had that here?
2 years.
Is it dusty?
Uh-huh.
Yeah.
Pyramid. Okay? Slant height is that side. Vertical height is if you went from the peak to the base. Okay? So slant height is the hence why they call it slant, because the side of a pyramid is slant. So they call it slant height. It is. Sometimes you can map. Exactly. See where this is all going to lead.
Yeah.
Okay. What happens here is that you can have the height is perpendicular to the base. Okay. The height of these things will be also in the center of the base. Okay. Excuse me. Our bases can be square, triangle, rectangle. Well, actually, probably won't be a rectangle. It'll be square. It's usually regular polygon stuff. Okay, so you're usually looking at regular polygons for this. The slant height, obviously, is like I was saying, is this diagonal height of the triangle. Now, this diagonal height, if it's a triangle, usually you're looking at isosceles triangles for the sides, which means it's going to be the perpendicular bisector. So usually, the slant height we use a different letter for too. We use a cursive L. We use that for slant height, I guess, because there's an L in the word slant.
And we already use S for side.
Correct.
So we go to the next level.
So this is going to be called our slant height. Now, which one's going to be longer, the height, or which one's going to be greater, a height or a slant height?
Slant height.
Slant height. Why? You're all close, but it's the hypotenuse, right? That's also the hypotenuse. Ross, put away your phone. Really, you don't need your phone now. You really, really don't. You guys have 5 weeks or 15 days of school left. You can get off the phones, you can stay off all the other crap you guys do, and worry about everything else. Slant height and the height create right triangles. Slant height and the heights create right triangles, which means that you're going to, I should be using yellow, you can barely see that.
And by the way, that's a cursive L.
The teacher, Connor's learning cursive right now, and he's actually really good at it. He's got very nice
I
cursive
mean, they
handwriting.
put you at third grade, but then you forget it. Yeah.
So that slant height, you'll see right here, you're going to get you'll get Pythagorean theorem. You're going to get 30, 60, 90s. You're going to have SOHCAHTOA. You're going to have all of that fun stuff coming back again and again and again. Which gives us formulas. So, surface area of a regular pyramid. Surface area of a regular pyramid. What does big B stand for again? Base. Yeah. Surface area of a pyramid is going to be the big B plus half perimeter times slant height, where big B is the area of your base.
And big P.
Is the perimeter of that base. And cursive L is your slant height. So when you're dealing with these things, it's, again, it's just a matter of writing out what's the formula, what's your base, what's the formula for finding the area of that base, and going from there. It's boom, boom. It's very, very, very procedural. Okay? There's not a lot of waywardness to it at all. Which means I could probably do you guys this. Yeah, right?
Yep. And this is the same one that you're, oh yeah.
Yep.
You did the final?
This is the exact same thing you guys will see on the final. And it has the formula sheets of all the stuff that you will be given. No, I got bored. Stop counting.
Will you grab a spare for Justin for me, please?
So, this is the exact same sheet that we provide for you guys, well, maybe different color or whatever, but you will see something just like this on the final. It's usually on the back page. We usually say, hey, just tear that off, you've got your formula sheet throughout the whole thing. Like we said, we're not making you guys memorize these formulas out and whatnot, but now you have all the formulas. And it tells you with your subscripts and all that, what you're looking for. So it doesn't say what all those values are. So that's the kind of stuff you have to remember. Okay, so you'll have to know what big B stands for. You'll have to know what P stands for. Okay? Does that make sense? Thank you, sir. All right. So it's just a matter of really identifying the shape. Thank you. Identifying the shape and just putting something together. Let's look at an example. Now, I did my best. It's very difficult to find three-dimensional shapes that look like they make sense as far as things are concerned here. But think of that as a square-based pyramid. And we're going to find the surface area of said square-based pyramid. An easy way to draw that by hand.
Draw the square and then draw the four.
Yeah.
lines.
Because these triangles, or all four of those triangles really are the same. It's just very difficult. So it's basically this, is what that is. Okay. Okay. What's the big B? It's the base. What's the shape of the base?
Square.
It's a square. So, just like we've been doing, just like last week, big B is a square, which means it's a side squared, which means this is, I'm just piecing it together. Okay, let's start with that. If each side is 10 and there are 4 of them, pace yourself. I don't know if you can figure that's tough. I know I'm asking a lot. It's Monday. Is it 30?
Oh, I thought it was 10.
Perfect. Now, how do you find this slant height graph? Pythagorean. Right. And that's kind of usually what happens here. You're going to have some extra step to find one part of it to go through. It's not always you'll have all the parts to it. Just very similar to everything else we've done throughout the year. Also, you might recognize it as a triple. 5, 12, 13. Put everything, write down what you're going to put in the calculator before you put it in the calculator.
How'd you get 13?
It's a triple. 5 squared plus 12 squared is 13 squared. So you use Pythagorean theorem, or I would just recognize you have a triple, and you'll be all right. One of the things that they will do, I think I'll have an example here in a second, is sometimes they will give you the diagonal height. the diagonal edge that, of the triangle, where you know you have an isosceles, and you have to build it out of that. Sometimes they do that. We got it. Visual aids. So let's see, half of 40 is 20, 20 times 13 is what, 260? 260 and 100 is? 360 something squared. Surface areas are squared. Side, it's an S, sorry. I wrote down a base was a square, which is side squared. So that the side is here. That better? Because it's a square. Come on, it's almost June. Don't you understand my chicken scratch?
No.
Alright, let's see. That's a cone. And just like think about it earlier, if the area of a surface area of a pyramid was the area of the base times half the perimeter, oops, why is this? Times the slant height. Well, what's the perimeter of a circle? What's that called? Circumference. So if, well, first of all, every cone has a base of a what? Circle. So that means that's why it's a, if the base is a circle, that's why it's equal to pi r squared. The perimeter of a circle is 2 pi r. And then this L is still your slant height. Well, watch what happens. If you put this into the original, you'd have pi r squared plus 1/2 of 2 pi r times L. What's half of 2? 1. Isn't it always going to be half of 2? It's always half of your circumference. So that's why they shortcut it and they write out the surface area like this. Where this is still your slant height. And that still is your vertical height. So the cones you're just gonna have in terms of pi, just like we did with what are those called? Cylinders. So it's nothing too crazy. Lots of formulas. Change my medicine. That's my why. But it's all thanks, Austin.
Just gonna feel that real quick. Thank you.
Not a problem. So, just like before, you'll have that vertical height of a cone. Somebody steal my concrete cone. I had a concrete cone. Huh. Use your chair like this. Put footprints on it, just to yeah, concrete cone. Oh, no, I actually, one of the projects a kid made, he made a cone out of concrete. It was really cool. It was bigger. Anyway, so cones, obviously, we've all seen a cone. You may or may not have had to wear a dunce cap at one point in your life. Your vertical height, treat it exactly the same way as you would pyramid. They kind of do the same thing, except the sides are curved. So, They don't think they have the Great Pyramid or Great Cones of Egypt
No,
or Giza.
no.
Those are pretty nice.
So anyway, once again, you'll have cones that are standing up, cones that are sliding down.
Why is it on the side?
We could have that on its side. It could be
Snow cone mode.
it could be snow cone mode. Exactly. It could have a whole bunch of stuff. All right. It just all depends on how they dry. Now, in this case here, you have 6 is showing it as a, what do you think? A radius. 8 would be the what? The height, but is it the slant height? No. So what do you do to find the slant height? Pythagorean theorem again. Okay. Now you might also recognize that, oh, it's a triple, isn't it? What's the slant height? 10. 6, 8, 10 is a triple of, is a multiple of the 3, 4, 5. It's a 3, 4, 5 triangle double. Now, if you don't remember it, it's fine. It's not a big deal. You can go back and use Pythagorean theorem, and it'll still work out just as well for you. And then it's just a matter of putting it all together. 6 squared pi plus 6 times 10 pi. Well, 6 squared is easy. 6.
That's 12.
Well, in some places it is, but not in here. So you have 36 and 60, which is 96 pi something squared. And just like we've done before, when you have stuff in terms of pi, why not just leave it with the answer? Because your calculators, if you typed in, still yours, if you type this in, 6 squared pi plus 6 times 10 pi, it gives you the answer in terms of pi. It's very crazy how that works, okay? So, as long as you type it in the right sequence, it should do that. If it gives you the decimal, whatever, it gives you a decimal, write it down. But make sure you put your units on there. So many people forget units. That's nuts. Half points everywhere. Half points everywhere. That's the wrong one. I had the other tab and figure out did not. There it is.
Still organized, but it's still messy.
Okay? Don't even try to draw this.
I'm trying.
That is a hexagon based, I think, yeah, it's a hexagon based pyramid, I forgot what they're called. Now, just like we've done before, we start always by writing out formulas. Big B, half the perimeter, times the slant height. What is this base? It's a hexagon. You're right, it has a side length of 12, but it's a hexagon. So what we do is we start by saying, all right, big B is a hexagon, which means it's going to be a 1/2 perimeter apothem problem. Okay? Just like every other time we had to write something out, we always start by what we know, what we have. Okay? Draw your 3 sides. When you're working with hexagons, that's all we gotta do. Who's it? This is the second floor.
That's why the 2 thing.
Oh, there's a 2?
Your left really creeps me out.
You creep me out.
You're welcome.
Got him.
Let's see why.
What's the outside angle in a hexagon?
72.
I don't know, maybe if you use some math, you can probably figure it out.
It's 30 outside.
Nope.
60.
60, yeah.
Gives you 120, which gives you a 60 here.
Yeah.
Which means you have a inside a hexagon. This is the short, this should be
30,
the
60,
easy.
90.
Yep. In a hexagon, you have your 30, 60, 90 triangles, which means opposite 30 is a 6, opposite 60 would be a 6 root 3. Now, if you forgot that, could you go ahead and use tangent and get the decimal? Absolutely. 30, 60, 90 triangles are your friends. So that means you have 1/2 perimeter apophthegm. Well, that's a 1/2 6 sides of 12 times a 6 root 3. That equals your big B. Just like every other perimeter apophthegm problem we've been doing since,
Since beginning of May.
May 2nd.
Since beginning.
So we've been doing that perimeter apophthegm problem started in May 2nd. So we've been doing them for a while.
It's still one.
And the formula didn't change?
It didn't.
No?
It's like this is the second floor.
And it isn't changed.
Perimeter of this base is 6 sides of 12. And the diagram gave you the slant height. You didn't have to worry about finding that. Okay. The diagram gave you the slant height of 14. So we put it all together. Big B, half the perimeter, slant height. 1/2, 6 by 12, 6 root 3, plus half of 72 by 14. It looks like there's a lot going on there, but I did not simplify anything as I was doing it. Because if I write down what everything is, I can type it all at once. Sorry. So if I do that, 0.5 times 6 times 12 times 6 root 3 plus 0.5 times 72 times 40, oops, 14. 878/12?
Yeah.
Everybody getting 878.12? Austin, I heard Austin got OCL shaking his head, yeah?
Yeah.
Excuse me. All right. I know that last week when we had a bunch of parentheses, people were having problems putting that in the calculator like that. One of the things you can do, instead of doing all those parentheses, you can just do 0.5 times 6 times 12 times 6 root 3. But make sure when you're done with that root 3, you press the out of the root 3. Because if you don't, then you'll take the square root of 3 plus the rest of the other stuff. But here's the thing. If you write down all of this and you give me the wrong answer, I know that's probably what you did. So that's usually what happens. Okay? You'll forget to hit the right arrow to get out from underneath the radical. It's such a common mistake. And then I just do a plus 0.5 times 72 times 14. Use 0.5 instead of 1/2 because it's easier to type in the calculator. Okay. Why are you shaking your head? Okay, very well. Okay, let's try another code. I'm sorry. Yes, sir.
Oh, I see.
Let's try another cone. Wow, imagine you guys were like packed. Hey, what's the one thing you had to do on this one that was different than the other ones? You had to find the radius. If that's the diameter, what's the radius? Cones are usually really easy.
L would be 18.
Bless you. Bless you.
I like just found.
Didn't need it because you've got your slant height. And remember, slant height, just think of it as what you would like to go down a sledding hill with. Yes, sir. I think it's just because it's the
Oh, yeah.
yeah. Because what you're doing here is that you have a 9 squared times a 9.
Yeah.
So it's a 9. This is 9 squared times 2. Does that make sense?
Yeah.
So what you're doing is you have a 9 squared plus a 9 squared. It's just
convenient.
yeah. It's just dumb luck in this case. Trying to think if I had the other room that was.
Would be 2 feet. What do you guys beat my sister? Will there be questions?
Yes, sir.
There'll be questions like, never mind, yeah, you're already doing it.
You might be able to just draw it. So you have a regular pyramid that has a height of 10. Its base is an equilateral triangle with base edge lengths of 12. So you have a regular pyramid that has a height of 10. An edge and it's a regular triangle. It's an equilateral triangle base of 12. So I am horrible at drawing.
You know what?
I know. I don't mean to crush your.
What is that? It's my new shape.
I'll take it.
Don't draw the bottom triangle, but don't make it equal.
Oops. Yeah.
I'm just gonna draw it,
So-
right what it is on the side.
Start with this. What's the base? The base is an equilateral triangle with sides of 12. Okay? It's an equilateral triangle with sides of 12. Now, if you have equilateral triangle with sides of 12, in order to find the area of that, it's going to be a 1/2 base times height. Are we okay with that? Now, when you do that, what does that do to the side? Cuts it in half. So we have a 6. And just a minute ago, we had a problem where we had a 60-degree angle. We had a 30, 60, 90. Where opposite the 30 was 6. Excuse me, was 6. So what's opposite the 60? 6 root 3. Good. So the height, I'm sorry, the area of this is going to be 1/2 12 by 6 root 3. Now, to get to the other stuff, we have to figure out, we had what, the vertical height? So we have the vertical height of 10. This was from the center of that triangle. Now, what we have to remember here is when you have a regular polygon base, which an equilateral triangle is, the center of that was always, the center to the side was always called the apothem. Remember that? So technically what we should, let me do this real quick. What we should have here, I know it's a triangle, I know a triangle actually touches all three sides, but if it's equilateral, can't we follow the same rules for regular polygon?
No.
You can't. Equilateral triangles is a regular is a regular polygon. Correct.
But you're talking about two different shapes.
What's that?
But you're talking about two different shapes.
But it still follows the same rules. What I'm doing here is I'm trying to get this distance here. Because I know that this distance to the side, since this would be my apothem,
But didn't it tell us it was 10?
no, the vertical height of the pyramid was 10. This, by finding the apothem, I'll be able to use my slant height. So, let's see if I have a better picture of this.
Yeah, you can't really have a visual of it.
Wish I had a triangle. This is a visual. What you have, we're trying to figure out what that slant part is, but we know we can figure out that we know that the apothem goes from the center of it and is perpendicular to the side. The height, the vertical height of this would touch the apothem. Yes, my finger would be 10. Please, look, it's a spinner. Oh, look.
Oh my gosh.
So we do the same idea. The exterior angle in a triangle would be 120. You okay with that?
Will it always be?
Yeah, because you take 360 divided by 3 gives you 120. Now we draw this in, and then that gives me 30 here. Okay. Now we knew that we had side lengths of 12s. We okay with that?
Sure.
Which means now, this is about as goofy as any of this stuff can get, is that you know that in a 30, 60, 90, you have side lengths of x, x root 3, and 2x. You know across from which of the three angles is 60. You know across from the 60 is 6. So in your calculator, you have to take 6 divided by square root 3. If I'm not mistaken, I think you get 2 root 3. So that means across from the 30 is 2 root 3. Which means that is my apothem. Okay. The 2 root 3 is the apothem, which gives me the other leg of the vertical part of the height. That's how far it is from the center out. It's 2 root 3. This is a very goofy style when you have an equilateral triangle. Okay, if you've got an equilateral triangle, you have to do a little bit of extra work with it because of the weirdness of the shape. That's also why on the extra credit thing, oh yeah, Ross and Justin, or Jordan, that's who it was. Remind me to give you one of the extra credit sheets so that we have the idea to do that. That's why I say don't do a triangle-based one. They're horrible to make. They're awful.
I can see this being a really good for word problems, like trying to draw and visualize it.
Yeah, but you know what? If you know that, let's say it's a hexagon-based pyramid with the sides of 8, you can just do this, get your area, and you know the perimeter, and if you know what the apothem is and a vertical height, or if you know the slant height, you can easily do it. But this is the hardest one, is the triangle one.
Yeah, like you get one of those goofy shapes.
Yeah. Sir.
What extra credit are you
Oh, that's right. You weren't here on Friday. I'll give it to you. I'll give it to you also. Sorry, forgot. So now we do 10 squared, 2 root 3 squared. So we have 100 plus, what would that be, 12? So the slant height would be the square root of 112, which is
4 root 7. I mean, 4.
4 root 7.
Yeah.
You're right.
That's the thing.
So big B was big B was our 1/2 12 by 6 root 3. The perimeter is 36 because there's 3 sides of 12. And our slant height, which we had to do all that extra work for, 4 root 7. Okay. That's where we got the square root of 112. So our surface area is 36 root 3 plus 1/2 of 36 times 4 root 7. 36 root 3 is half of 12 times 6 root 3. Half of 12 is 6. 6 times 6 is 36. And I just kept it in the radical form before I went on for that. Okay. Then you just type it in. So let's see here. 36 root 3 plus 0.5 times 36 times 4 root 7. 252.85. Now, so remember how you said your calculator spit out 4 root 7? I think it did it automatically, didn't it? Did it automatically give 4 root 7? Did you get the square root of 112 and then you hit the button or something?
No, I don't know.
Okay. Here's the thing. Does it really matter if you have it in simplified radical form before you put it all together? It really doesn't. And more often than not, your calculator is going to do that for you anyway. But if you're just walking through the process and you know that 10 squared is 100, and then if you do 2 root 3 quantity squared, you know that that's 12, you know that's going to be the square root of 112. You can put in square root of 112, but you're still just going to get the decimal. So there's, depending on how your calculator spits itself through. Okay. Let me give you a couple of these for this evening, and then we will do some combo shapes tomorrow where we have to worry about things that are covered. We have to back things up. So let's see. Oh, by the way, in the textbook or in worksheets and stuff like that, sometimes they talk about what's called lateral area. Disregard anything that you see about lateral surface area. That's just the surface area of the sides. We don't use it very often. Just, it's not something that's a big deal. Yeah.
She did what did come before attendance. Somebody must have told her to do this. And she did. She did this. She was like,
Okay. Got 10 of them, real quick ones. The first 3, they give you everything. You don't even have to worry about trying to find the perimeter. You don't have to even worry about finding the lateral or the, what do you call it, the slant height. Those last 4 are the ones you have to draw the pictures. Okay? That's fine. All right. Excuse me. We'll go from there. I'll have this posted here in a minute.
Is this like I watched it